almost from Paleozoic and then Mesozoic and Cenozoic and very close to Holocene. So look at the temperatures in the Eocene. So you have very high temperatures, and that is the time when our ancestors arrive on this scene. So overall, the temperatures have gone down since the Eocene, and why I am specifically focusing on Eocene and Paleocene, because before that there were no primates. So primates, or we are all primates actually. I'll tell you why and how we sort of are very similar to other lesser and advanced primates. So the overview of today's talk is why actually climate changes, why at all climate changes, and what are the various proxies through which we can go deep into the time and look at the climate changes. And what makes us primates, as I just mentioned, that we belong to an order called primates. That includes apes and monkeys and lemurs, lorises. So we are all primates. And then how does India come into play when we talk about our own evolution? Where does India stand? And then what are the various stages when early apes or primates, they change their morphology and diet and ecology. So that is how I would be basically well. Why it changes? So when we look at the Paleocene, Eocene time, and this was the time of hot house. It was a warm house. So the temperatures were very high, and then when we move into the Oligocene, the temperatures went down, and we are today in the cold house. Though there is a little flip of warm temperatures, which has happened maybe in the last couple of hundred years. So next please. One reason is tectonics. So plate tectonics, though it is slow, plays a major role in climate change. Look at the globe 65 million years ago. So you have a lot of these, Tethys is here, and there are a lot of Panama, there is no connection. So this was the time when the water could move around, the hot water could move around the globe. So that is one big reason why globe was so warm at that period of time. And today you have all these, most of the continents have moved northwards, and these seaways are now closed. Next please. So just to explain further, you have those currents now kind of cut now. The warm water now goes all the way up, evaporates, and then a lot of ice falls because you are in the northern part of the latitude, and it is kind of a chain reaction due to albedo effect. More and more ice falls and more colder climatic conditions. So one big reason is the passages are now closed, and that is due to tectonics, and then of course followed by these albedo effects. Next please. One big effect that tectonics brought about was upliftment of the Tibetan plateau. Imagine something which is now has gone a huge mass of land has now gone up almost 5 kilometers. So that makes an area which is exposed to sunlight, and that has changed the climate a lot. Next, please. So what has happened in the last almost 10-15 million years? So somewhere around 10 million years ago, we start finding that that almost the Tibetan plateau was almost 2.5 kilometers above mean sea level. Now, of course, it's 5 kilometers. So things started changing in the sense that the air got hotter in the plateau, and as air rose, it sort of produced a vacuum kind of thing, and that led to sort of bringing in the moisture laden clouds into the Himalayas. So what we see for the first time in the geological history, intensification of monsoons. There are a lot of claims, existence of monsoons much before that, but worldwide monsoonal conditions are seen around this very time period. Next, please. And then we have the Milankovitch cycles. The students might be very well aware of that our Earth's position vis-a-vis Sun's position, whether Earth moves around a circular path or an elliptical path, or its tilt, that is from 22.1 to 24.5 degrees, the tilt changes, and then the wobbling. With the tilt comes the wobble. So all these, that is called precession. So all these factors basically influences the climate. You imagine a time period when the huge landmass is tilted towards the sun. The Earth is moving closer to the sun. That would produce a very warm period. So these effects sort of combine in a way. You have tectonics, you have albedos, you have sun's the Earth's position with vis-a-vis sun. All these combined would bring in climatic change. Now, one thing I must say, that till here we don't see carbon dioxide making a big deal. So most of the climate change, what we have seen so far in the geological history, is due to tectonics, due to Milankovitch cycles, and other aspects. Next, please. So I have just kind of combined everything. Look at the overall picture from Paleocene to Eocene, that the slide I showed you, first slide. And as we see, climate has been fluctuating and kind of changing over periods of time. And this is where you have a combination of all sorts of effects, and that leads to ice ages. So this is basically this part of the